So what I wanted to do, I'm asking this question because I wanted to know how you would approach it. And by and large, you all approached it the same way. So because there is actually more than one way to do this problem, but I'm going to go with what you know. What you know is that you all said, I'm going to look at 1/4 plus 1/6, and what do you need to do? Common denominator. So 1/4 turns into 3/12, and 1/6 is 2/12, and you added those together and got 5/12. Very good. And then you also looked at the denominator and said, I need to add those, or subtract in this case, fractions, which means they would need a common denominator of 4. So that became 2/4 minus 3/4, which was good. And a lot of you left it like this, but can't you do something with that? You can. We don't like dividing by a fraction. What can we do instead? Multiply by the reciprocal. Okay, which would be 4/-1. Which we can do a little bit of cross reducing. So that becomes -5/3. So give yourself a pat on the back if you got that right. Good job. You're a swimmer. You should absolutely be able to reach your that. But you're so flexible this way. Like, I'm sure you can do the whole, like. All right. Yeah, touch your fingers behind your back. Okay. All right, ladies and gentlemen, today, is it hot in here or is it just me? It's so warm. It's just warm. Okay, just checking. These are complex fractions where we have a fraction within a fraction. All right. And we're going to do our complex fractions the exact same way, where we're going to look at the numerator and we're going to get a common denominator. And we're going to look at the denominator and we're going to get a common denominator. And put that together. And then the same thing, we're going to multiply by the reciprocal. It's a really good thing you didn't stab me in the eye with that. So, there you go. Example 1, simplify the complex fraction. Noel, what did you just say?
I said the next thing you know is going to be complex fractions and complex fractions.
They do have those. I didn't assign them to you.
Oh my god.
That's probably something we'll do at the end of the semester if I have time. But. All right, we have 4/a minus 5/b, all divided by 3/a plus 6/b squared. So I'm going to start by just looking here. And I think what I'm going to do is, I don't know, it's a lot of lines. So I'm going to write this as 4/a minus 5/b divided by, can I do that?
Yes.
Yeah.
3/a plus 6/b squared. Now, is that okay to do? Can I write it as a fraction divided by a fraction like that? Yeah, it's the same thing, different format. We're going to do the same idea though. Before we can actually divide these two, we have to simplify within the parentheses. So here I need a common denominator. What should I multiply the first fraction by? B, yeah. On top and bottom. And the second fraction we should multiply by? A, on top and bottom. And so that becomes 4b minus 5a over ab. Very good. All right. And then looking at my second fraction now, again, we need a common denominator. So what should I multiply the 3/a by? B squared on top and bottom. And On the second fraction? A on top and bottom. Awesome. And so what's my numerator going to be? 3b squared plus 6a over ab squared. Perfect. All right, now that we've cleaned those fractions up, and now we have a single fraction divided by a single fraction, as opposed to some, two terms, two fractions. Now we're going to do what? Reciprocal. Keep, change, flip. Multiply by the reciprocal. Okay, so I'm going to take my same 4b minus 5a over ab, and I'm going to multiply by, what's on top? ab squared over 3b squared minus 6a. Plus, thank you. Sorry. Thank you. Good catch. And you were all right there on target. Nice work. So we're simplifying fractions now, rational expressions rather. Is there anything we can do like factor-wise? Can we do any factoring? No. What? We can take out a 3, so I kind of want to do that. There is a GCF here. It's not going to change anything, but I want us to be thinking about that. We have to bubble if we can. So 4b minus 5a over a times b. This is a times b squared, and I'm going to take out that 3. What's left behind if I take out the 3? b squared plus 2a. Okay, so it wasn't really helpful, but I don't want you to forget that you do that. All right, and so what's going to cancel out? A on top and A on bottom, and one of the B's and one of the B's, which means we're left with what in the numerator? B times the quantity 4b minus 5a over 3 times the quantity b squared plus 2a. What did you say?
I like blinked and
Oh. We canceled out our A on top and A on bottom.
Oh, okay, now I see it.
Okay. All right. Yeah. This was b squared, right? B times b. So one of those b's is going to cancel out with this guy in the denominator, which means there's one extra, one left on top. Yeah. All right. You'll notice I left this in factored form. Do I need to distribute my b in? No. Don't do extra work. Okay. All right. Oh, by the way, you're going to have tests on Wednesday.
Okay.
Yeah.
No, like the day after. We're going to review tomorrow. Yeah. Yeah, this test is factoring and rational expressions. That's it, 2 sections. It's actually a pretty easy test. All right. So letter B. I have a fraction, a numerator, divided by another fraction, right? What is this fraction? H over 1. And maybe you need to do that. Maybe you don't. I think it's helpful for now. All right. Can I factor these denominators at all? No, they're prime. All right, so again, I need a common denominator to add or subtract these fractions. So what does this first fraction need? X on top and bottom, very good. And what does this part need? X plus H, X plus H. So I heard just an H, and that's a pretty common mistake, just to add H, We cannot add top and bottom. We must multiply top and bottom. So you have to multiply by the whole factor, x plus h on top and bottom. So what is our common denominator? X times the quantity of x plus h. Very good. Now my numerator, I have a 3x. And what else? Ooh. Did you distribute or did you leave it in a quantity?
I wanted you.
You left it. Okay, so negative 3 times the quantity x plus h, like that. Good. So when we leave it negative 3 times the quantity x plus h, you're more likely to simplify that correctly. And then if you distribute your negative 3, what are you going to get? (3x) and then what? Minus 3x minus 3h. And what happens? Positive 3x and negative 3x goes away, so that's nice. All right, so now I finally cleaned that up. I hope you can maybe do that a little more quickly eventually. You know, I think you have 10 problems for homework classwork today. Okay, so here is my numerator all cleaned up. And I'm dividing by this h over 1. So what can I do instead of dividing? Times 1 over h. Very good. So multiply by the reciprocal. And then what happens? Yeah, h on top and h on bottom cancels out. All right, what's left? Negative 3 over
X.
Good.
Not all.
That's it.
Wow.
Questions on B?
It's a little confusing, not gonna lie.
Oh, Eric, you're fantastic.
I'm not kidding, dude.
Look, that was 2 problems with the whole piece of paper.
That took me 2 pieces of paper because I didn't see it.
All right. So we've got, here's one more.
Oh.
This is what I do.
All of you at some point will come to in your lives be taking a math class and you'll realize that all of a sudden there are no more numbers in math.
Literally.
Ever. Alright, so at the beginning the question was posed, are we gonna get complex fractions within fractions?
Yeah.
Oh, here it is. Alright. The idea is the same. This is a complex fraction, and I'm just going to go ahead and clean that up first. Okay? All right, so just looking at this y over, I can rewrite that as a fraction, y over 1, divided by 1 minus 4 over 1. You're good with that, right?
Yes.
All right, so over here I need to clean up my fraction minus a fraction, so I need a common denominator. So I'm going to multiply by y over y. All right, what does that become? Ooh, careful. Y subtract 4
No idea.
over y.
I mean,
Put it.
yeah, shizzles.
Okay.
And then you do the reciprocal.
Sure. Yeah, we're going to multiply by the reciprocal. All right, so that's going to be y divided by 1 times what over what? Y over y minus 4.
Y squared.
Ah, yeah. Nothing cancels. Super.
Is it just?
And then we go back to the 4.
All right, where are you confused?
Well, then it's just 4 minus that. Like that. So like y over divided by.
So here's the y over 1.
Yeah, I got that.
Yeah, divided by 1 minus 4 over y.
Y times y on my. But isn't it? Oh, that's yeah.
Got it?
Yeah.
You're with me now?
Yeah.
Good, good. We're not done yet.
How do you know when to cross? I feel like that's my problem.
Yeah.
I don't know.
That one's like.
So now that it's multiplication, now we would be able to cross reduce. Okay. But nothing cancels top and bottom. Like there's nothing, no bubbles I can pop right now. Okay. So now we've cleaned up this complex fraction. So now I'm at 4 minus y squared over y minus 4. So now I'm back here. Now this is just a fraction minus a fraction. This is what we did last week.
4 over 1.
4 over 1 is an excellent start. And how do we subtract fractions? Common denominator. Okay. All right. Yeah. So here's our denominator. We're going to multiply over on the left here, the left fraction, y minus 4. On top and bottom. So what's my common denominator? Good. Now what's in the numerator? Can I distribute the 4? 4y minus 16 minus y squared.
Do you have to distribute?
Yes. Distribute the 4.
You have to.
I mean, you could leave it like 4 and then distribute, like you could do in 2 steps. But I'm gonna rearrange this numerator. How does that numerator rearrange? Minus y squared
Minus plus 4y.
plus 4y minus 16. Good. Why would I need to do that?
Factor.
To check to see if we can factor it. What's this negative? What am I thinking because it's got a leading negative?
Distribute it. Take it out.
So, yeah, there's a GCF of -1 that I could take out. How would that change the numerator? Y squared minus 4y plus 16. Okay. And then I'm just checking to see if this is a double bubble. Does that trinomial double bubble?
Yes.
Yeah.
No.
I don't know.
Yes.
16 times 1, negative 16 times -1.
Oh no, it doesn't.
Never mind.
Negative
I hear myself.
4 and negative 4, or negative 8 and positive 2. And is that gonna work?
No.
No. Okay, this is our final answer.
Dang, I guess it's long.
That's why you only have 10. All right. The best way to figure it out is just to try it out. Ladies and gentlemen, you have class practice 18.
Are we done?
Yeah.
All right. Brian.
What's up?
You mean Rose?
Alright, I bet.
Oh,
Wait,
wait.
you guys are
I'm done with this.
Oh,
I already got one. You can put this
Yeah,
back.
you can. I think it's in mine.
You already got
Yeah,
it?
just, yeah, it was not.
Yes.
I know you like
What?
I didn't ask him to do it.